Thank you very much. It is good to know that the bake-off viewing figures will be down by about 400 tonight. So if you feel the need to tweet about it during the event, please feel free. I'm always looking at events like this for things that touch on the interface of science and real life. And the subject matter that we landed on tonight seemed absolutely tailor-made for where real hard-nosed science meets myth. We all think we know something about stress, and meets our everyday lives in the science of stress. We've put together 3 super speakers for you tonight. One from the University of Cambridge, Joe Herbert, he refused to tell me how many decades he's been working on stress. Maybe you could ask him at question time. I think that would be a reasonable question. The second speaker will be Julie Turner-Cobb, who works on lots of aspects of stress, but we've asked her tonight to emphasize her work on stress in childhood. And the third speaker will be Shane O'Mara, a professor of neuroscience from Trinity College Dublin, who will speak on extreme stress and the effects of stress on memory under torture. I encourage you to look at the books of Julie and Shane out there. Julie's on child health psychology, and Shane's on Why Torture Doesn't Work, a very consequential book, which ended up with him as the rapporteur at the United Nations General Assembly just last week. So if you can welcome our 3 speakers, please, Joseph, Julie, and Shane. Joe. They're going to speak for 15 minutes each. If they go on for longer than 15 minutes, shuffle uncomfortably. Make them know it, because they're eating into your time to ask them questions. And the real point of tonight is so that you can have access to the open minds of 3 experts. So, Joe, please.
Thank you very much. Good evening, everybody. As you heard, I'm going to talk about stress. I'm going to begin with the traditional thing that all scientists begin with what do you mean by. It's important, actually, because stress is a widely used word, and it's actually very much misused. And let me tell you a bit about how someone like me thinks of stress, and which may or may not be the way you think of it. The first thing about it is that it's along various dimensions. You would have physical stress, no food, or dehydration, or hot and cold temperature. And these are real stresses, and they're important ones. Of course, you have personal stresses, which means things going terrible in your life, like a loss, bereavement, for example, or a loss of a job, this kind of thing. These are all the stresses. Then there's social ones, like, for example, relationships and friendships and your status in the community and so on and so forth. And the first point to make of priority, of course, is these aren't separate. They overlap, of course. You can see that, can't you? And can overlap. Now, the important thing about a stress is that it isn't actually out there, it's in you. Nothing is actually a stressor unless the body regards it as such. So it's a highly personal, individual event. And whilst, for example, a high temperature may be a stress to most people, there are some people, of course, which it is not. And the same goes for starvation and so on, and the same goes for bereavement and all the rest of it. So it's an individual thing. So the important provision here is that the perception. Now, this is the big problem here, because this is the external event, and this is the response. And people use stress for both the external event and the response, and they're not the same. Engineers call this strain. It's a much better response, but biologists and medics don't talk about strain, they talk about stress responses. And this goes again across 3 different interlinked mechanisms. There's the physiological, what your body does in hormones and things, and I'll talk about this in just a moment. There's emotional, in other words, how you feel about it, and there's cognitive, which is really basically what you do about it. And the result of this is, of course, that you adapt or not. But even if you adapt, there's usually a cost, even if you don't know about it. And that's the point about stress. Even a successful or apparent successful adaptation may imply a cost. Okay, now, one particular sort of stress is what's called a life event. And here are some of them here. These are the things that can happen to people here like this, all right? And they can be either acute or chronic, or more commonly, acute on chronic. For example, poverty or deprivation is a chronic stress. Losing your house, which may result from poverty, is an acute on a chronic stress, and so on. The important thing I want to talk about there is this. I'm going to link stress with depression, because that's my focus this evening. And the important thing is that most episodes of depression are actually preceded by an identifiable stress. Not all of them, and there are reasons for that, but the converse is not true. And that means that there must be some mechanism for resilience or susceptibility to stress. And the question is, what do we know about that? Here's an example of what might happen. This is a graph here. This is the risk or the risk of getting depressed, and this is time. And what has happened here is that in 207 women, either they've lost their husband or their husband has had a serious heart attack, so he's in danger of dying. Now, three important things here. First of all, as you can see, about 20 weeks later, there's a great bulge of mental response. So the first thing is, what's happening in that interval? The interval varies. Some people say it's less than that, but there is an interval, and that's what happens. So what's going on? Second thing is, as I said to you, not everybody does it. In this case, just over a third showed some kind of mental disorder here. And the third point is, it wasn't all the same mental disorder. Some were depressed, some had an anxiety neurosis, but of course the two, as you know, can coexist. All right. So what do we know about what happens? The brain. This is what I do, the brain, okay? And this is where it all happens, because as I've said to you, stress is a brain event. If you're stressed, it's because your brain is in a particular conformation. Now, this is a cross-section of the human brain. There's the midline, there's the top, there's the bottom. Now, this bit here is called the cortex, and it's the kind of radio 3 part of your brain, the kind of thinking bit, the intellectual bit. And that recognizes the situation, because it is the basis of perception. Now, it doesn't actually necessarily imply or assign a value. It just analyzes the situation. What is happening? There's somebody in front of me with a little L-shaped piece of metal in his hand. I recognize that as a gun, right? That's what the cortex does. Down here in the amygdala is the response, the emotional, which in this case is it dangerous? Incidentally, the amygdala can also do the opposite. Is it pleasurable? But we're not here to talk about pleasure. We're here to talk about pain. Is it dangerous? Now, then what happens? Well, another part of your brain, the hypothalamus, organizes the response to it, because your body needs to react to this, and quickly. And that happens down here. And the hypothalamus does it by sending a signal, a chemical signal, down to the pituitary gland here, and the pituitary gland sends another chemical signal down to the adrenal glands. These sit in your abdomen, just above the kidney side, okay? And the adrenals do what is necessary, and that is produces masses of this hormone cortisol. And that's where our story starts, cortisol. Here is cortisol. Now, I'm in big danger here. I'm always told if you show anybody a molecular formula, all the audience goes to sleep. So before you go into coma, let me tell you why I'm showing you this. Now, these black things are carbon atoms. If you look carefully, you see there are 3 rings of 6 carbon atoms each, and they share atoms, and one here of 5. And I'm showing you that because that's a steroid. All steroids look like that. Now, what makes one steroid different from another steroid? This is cortisol. But of course, the whole audience here has another steroid called testosterone in it, males and females. And the ladies and the men have estrogen, and the ladies, some ladies anyway, have progesterone. They're all steroids. Now, what matters are these things here. These are oxygen and hydrogen atoms. And if you rearrange them, you change the function of this molecule. Quite astonishing. So it's a very simple molecule. Compared with a protein, which is a molecular weight of thousands, this has a molecular weight of about 300. That's nothing. And yet, it's one of the most powerful substances we know. Why? this. Without cause, ladies and gentlemen, you're all dead. And in fact, Addison's disease, Thomas Addison was an 18th century physician from Guy's Hospital, down the road here, described it, and he didn't know why they all died, but they all did die, his patients, and he noticed that they all had great chunks of tuberculosis in their adrenals. In those days, tuberculosis killed 1 in every 4 people. Do you know that? It did. Anyway, and of course, nowadays, people with Addison's disease don't die because they're given cortisol. But if you weren't, they were. So it's important. Has a marked data rhythm, which I won't go into. This is something we'll come back to. Women characteristically have about 20% more cortisol in their blood than men. Does it matter? Wait. Stress. It is, as we've seen, one of the most, not the only, but one of the most dramatic moments, one of the most dramatic events in response to stress. You need it. People with Addison's disease have to increase their cortisol dose if they get ill. Otherwise, they get very ill. So you need it. Okay? Whoops, that's not right. Okay, there's lots of things here. And the only one I want to talk about is that thing here. Because we know from a whole variety of studies, both in normal people and people given steroids, that steroids, cortisol, can predispose you to depression. It can cause depression. And it does in many people if you give them high doses for a long time. Okay, so that's cortisol. Now let's get really trendy and talk about genes. Here's a gene, a very interesting gene. It's a gene to do with serotonin. Now, as you know, classically, serotonin is related to depression for a variety of reasons, which I won't go into now. But let's look at this particular gene here. Now, this gene exists in 2 forms, a long form and a short form. And about 25% of you have 2 longs, 14 have 2 shorts, and the rest of you have a long and a short. Do you know? No. Do you care? Well, you might in a moment. I'll tell you why. Look, this is a study done, a very, very famous study actually, done as the most cited paper in the whole of behavioral genetics. And this is why. This is a study on about 1,000 young people. And they did 2 things. They determined their genotype, and secondly, they asked them 2 questions. How many life events did you have in the last 5 years? And have you or are you depressed? Now, as you can see here, those with no life events, the gene did nothing. But as the life events increased, in other words, their lives became more stressful, you can see what happened, can't you? Those with the 2 shorts had about between 30 and 40% of depression, whereas those with 2 longs, well, it barely increased, and those with half and half were in the middle. A fascinating, fascinating example of a gene time and environment interaction, which we all talk about, but we very rarely see with such clarity. A brief mention of childhood. Now, Julie's going to talk much more about this, so I'm not going to say much about this. I just want to very briefly make the fact that childhood adversity comes in various forms. Here they are, again they overlap, and there are prominent consequences, which again I'm sure Julie will talk about. We all know about that early adversity has long-standing effects on later development. The question is why? Why is the infant brain, the neonatal brain, the young brain, so apparently sensitive to adversity? Now, just recently, we've had one inkling of why this might be, and I have to introduce you to the very modern and contemporary and very sexy field of epigenetics. And here it is. Right, now, this thing here is a strand of DNA. DNA, of course, you remember, is like a long necklace with 4 colored beads in, and the order of beads matter. That's the code. It's wrapped around these proteins called histones. And on these things, there are certain little sites which here are not occupied with anything, but can be occupied by a methyl group. And those of you who want like chemistry, that's a methyl group. Now, what that happens is called methylation. What that happens is 2 things. First of all, the DNA changes its shape like that, but much more interestingly, it stops working. So that gene suddenly doesn't work. Now, how can that happen? Well, it can happen as a result of an environmental event. In this case, this is a rat. Now, rat mothers like human mothers, vary in how good they are. Some rats are very good, and as soon as their little ones stray around the nest, they pick them up and bring them back. Other mothers are a bit more nonchalant, and don't look after them. They don't lick them so often, they don't look after them so well, don't care for them so well. When they grow up, those little baby rats show a marked difference in stress responses. The ones with the poor mothers have an increased stress response. They also have an increased methylation of this gene. The important thing is that this methylation can last a lifetime. Now, two big questions here. How does the brain know? How does that gene know about the mothering? What's the link between the mother, her mothering capacity, and what happens in the brain? We don't know. Secondly, can we undo this? In other words, if this is a deleterious event, can we undo it? Not so far. But that's where epigenetics is going at the moment. Fascinating area. Okay. Third thing which predisposes you, so that's early environment and epigenetics. The fourth, or wherever I got to, number is gender. Bad news for ladies in the audience. 1 in 4 of all women have a diagnosis, have an episode of clinical depression, which is a very frightening statistic, but it's true, whereas only 1 in 8 or 10 men do. Why? Well, here are the possibilities. Genes. What about the, this, by the way, this Winston Churchill had, as you probably know, had repeated depression all his life, and he used to refer to this as his black dog, and there's a black dog. Anyway, genes, all right. Well, we don't know about this, but of course, as you know, females have 2 X chromosomes and males only have 1. Is this a factor? We don't know. Early adversity, well, that's not different in males and females, but can we counter, can we recognize people who are permanently disabled or permanently damaged by early adversity and do anything about it? Not so far. But once you understand the mechanism, you begin to look at a remedy. High levels of cortisol. Well, as I've said to you, women do have high levels of cortisol, and that, we think, might push them a little bit nearer to the precipice of depression. Life events. Interestingly, women report more life events than men. Now, big argument about this, which I'm sure all the feminists will love to join in. Do women really have a rougher time than men? Yes. Or are they simply more sensitive to adversity? Possibly. We haven't decided that yet, but the fact, yes, I'm on dangerous ground here, I recognize that. But the fact is that women do have more life events, they have higher cortisol, and they have different genes. Now, we don't know whether any of this combination is actually increased depression. The last thing I want to say about depression is this. I've been talking about it as if it's a single illness. It's not. It's not. We now know from a variety of chemical and biochemical and neurological and indeed psychiatric bits of evidence that depression is not a single illness. So we have another complication here. Are there different sorts of depression, and do different sorts of stress increase different sorts of depression? And the big problem here is we have no idea of what happens in the brain in depression. Do I have another minute, or I've finished?
I think
I've finished.
While you're alive, on Safe Trying, we've got lots and lots of things there. Thank you very much, Joe. Thank you. Thank you. Cortisol, depression, genes, epigenetics, sex politics, so nothing much to think about for questions there. Maybe we can eke 1 or 2 out of that. Julie, do you want to take on the discussion with childhood and stress? Thank you very much. Thanks a lot.
Okay, so I'm going to talk to you about the interaction between psychosocial factors and psychosocial stress and health across the whole lifespan. So one of the questions I want to think about is, can stress actually be good for you? There's a lot of bad press about stress, and obviously stress is very frequently negative, but can it be good for you? So just bear that in mind. Now, if you think about the early years, they have a huge impact on your health trajectory right across the lifespan. So there's almost an exponential increase, that the early years have this much greater effect. And by early years, I mean childhood and adolescence. But what can be done about that? Well, stress, as Joe mentioned, is this interaction between the person and their environment. And we can categorize stress in all these sorts of different ways, whether they're major life events, minor life events, daily irritations and hassles. And we might say stress is mild to severe or tolerable. Sometimes stress can be tolerable, but then it may be the other extreme. It may be toxic, it might be acute or chronic. So we can categorize it in all these sorts of different ways. But whichever type of stress that you're talking about, there are four characteristics that really define stress. Excuse me. And the first of those is something being unpredictable, but also something being uncontrollable, having an element of social evaluative threat, social judgment, and also time pressure. So if you've got an event that combines all of those, you're going to feel really stressed in whatever degree. And whilst we categorize stress in those sorts of ways, of major and minor life events and hassles, the current thinking is really that stress is much more like a mosaic. And you have all sorts of stresses thrown at you at once. Stresses happen simultaneously. And you can have compound stresses. So you know the old adage, it never rains, but it pours. Once one stressor happens, all these other things tend to happen. So stress is more like a mosaic, as one way of thinking about it. And we've already heard about the epigenetic aspect of the environment and genes. Well, the orchid gene hypothesis proposes that some children are actually more vulnerable than others to stress. So some children, they can flourish, they can be resilient and do very well, but only if they're in a very enriched and supportive environment. And at the other end of the extreme are resilient children, what is known as the dandelion children, who can flourish in whatever circumstances. And obviously, most people are somewhere in between rather than one extreme, but it's a good comparison. And as a psychologist, we're interested in what these resilience factors are that help children cope so that we can perhaps intervene and promote coping and improve health. So another way of thinking about stress, then, is adaptability. I won't bore you with too much theory about stress, but just to say there are two important concepts within stress, and these are the concept of allostasis and allostatic load. Now, allostasis is the stability through change. As Joe was talking about, these different types of stresses. Stress can be physical as well as psychological, and it's a psychological stress that triggers a physical response or physiological response. And the greater amount of change that you need, the greater adaptability, comes at a cost. So you can actually adapt to a great number of different stressors. The body is engineered in such a way that you can physically deal with a lot of stressors. But it comes at this cost, and that's your accumulated lifetime stress or your allostatic load. And the way that your physiological stress response system becomes set early in life may mean that you need greater or lesser amounts of adaptability and generate greater or lesser amounts of lifetime stress. And that seems to be what's associated with health. So if we think about stress in the context of development, there are a number of changes, developmental changes that are going on. You've got biological maturation, where there's a development of the immune system and the development of endocrine hormone systems. And these are all part of the stress response system. And there's cognitive understanding that's developing, language development. If you can't understand how to cope with something, then it's more difficult to know what to do. Attachment and learning are developing, and social relationships are very important, we know, in protecting you against stress. So whilst the stress is ongoing, within childhood and adolescence, you've got this backdrop or this context of these developmental changes. And what I'm really interested in is how the physiological system or stress response systems can become set at an early age, which may then influence this health trajectory. Now, there are many different types of ways to look at stress in children, but there are two particularly good paradigms that have been looked at in the literature. There's looking at childcare and also starting school. So I'm briefly going to mention those two. This is some work done by some very prominent authors, researchers, and you can see that this is comparing childcare experiences. So those children who are looked after in either a large centre-based childcare arrangement or more like a childminder small group, and comparing good quality and poorer quality daycare. This is an American study, so nursery care we would call it. And as you can see, as Joe mentioned, cortisol is essential to life. And also what we find across the day is that there's a natural rhythm of a high cortisol level in the morning, declining steeply across the day. And that's a good response. That's a normal, natural response. So as they found here, you can see the children in the, if I can point, in the top line here, these are the ones who are in smaller group care of good quality. You can see that their decline in cortisol across the day was nice and steep. That's a good response. That would be associated with better health. In fact, it's even steeper than you see in the control group of children who didn't go to childcare. So you can see here that actually childcare wasn't a bad thing if it was of good quality. And in work that I've done previously, we've looked at children transitioning to school. So that's a natural, normal stressor, transitioning to school, and you would expect to see a cortisol response. In fact, you want to see an acute response to starting school, an increase in their cortisol levels, because that indicates much more adaptation. So you can see here, this is children who are in the study for up to a year, and up to 6 months before, this is their average cortisol level. This is just in the red here, just looking in the mornings. And then when they transitioned to school in the first couple of weeks, and then 6 months after that we followed them. And you can see here that they had a rise in cortisol, in their mean cortisol, as they went to school, as you'd expect, and then quite a dramatic, significant adaptation, which is also good, within the first 6 months. So this is a good response. We weren't saying that children shouldn't go to school, that they should be protected and bubble-wrapped and always stay at home and never interact with teachers or other children. In fact, this was good. We expect to see this response. And when we looked at physical health, what we found was that those children who had a higher cortisol level when they transitioned to school were actually the ones who were less likely to become ill across the next 6 months. So in that respect, within this healthy population, acute stress, within the normal ranges of cortisol, you can see that stress is actually quite good for children in terms of their physical health. Okay. So another way that we look at, as psychologists look at stress, is to not just look at stress naturalistically in the real-world environment, but to take that into the laboratory and look at experimental stress in the laboratory. And this is a typical paradigm. This one is just a mock-up, but this is a typical paradigm where you would have these are the experimenters, the panel, where they would put the participant in front of them, and they would ask them to do a talk. They'd put a camera in their face and get them to do a talk, and also a maths task, a serial subtraction. Some of you may have done this as participants. And this reliably in adults produces a stress response. And we can look at all sorts of things such as how different individual differences contribute to that stress response, and also different coping mechanisms. Now, in children, so this works in adults, but in children, the results are less conclusive. Some studies have found increasing in cortisol and other allostatic markers, but not all studies. And one of the reasons, I think, for this is because all of the studies, until recently, for children were using an adult panel. So in order to stress children, they would use an adult panel. Whereas often the stresses for children within their environment, remember that stress is an interaction between the person and their environment, a lot of the stresses for children seem to be from their own peer group, from school, from their friends. So what we did, was to change this, and we actually put children on the panel as the experimenters. We filmed this, otherwise it would be impossible to repeat identically for each trial. And what we found was that, as you'd expect, this line here, you can see children increase in response to stress and then decrease. But we actually found 3 groups of children, and we interviewed them afterwards, and we said, what did it feel like to be put through that paradigm? What was your experience? And what they told us in interview was very, very eloquent. They were able to tell us exactly in line with the cortisol results. Obviously, they didn't know their cortisol results, and neither did we at that point. But what they told us, whether that they felt stressed and then they felt better, that actually they didn't find our silly test very stressful at all, and they were really cool and too cool for school, or that they felt stressed and they still felt stressed afterwards, even during the debrief session. Obviously, they didn't feel stressed by the time they left the laboratory. I'd just like to make that point. So what we found, that children are actually not only truthful, but they have a very good insight into what their own stress responses are. You don't find the same when you ask adults. Adults generally, you'll see this, the cortisol hits the roof, whereas they'll say, no, I was fine, I didn't feel nervous at all. Okay. So what about longer-term effects of early stress? It's all very well to look at starting school, childcare, putting people in the lab, but what about these longer-term effects and much more severe stressors, as you can see here? Well, we know that these early life experiences can have negative effects on health if you project forward in young adults, in middle-aged men and women, also in the elderly, across a whole range of different physical conditions, from cardiovascular conditions up to different pain conditions. But we also know that if you can intervene at different points here, you may be able to reverse that damage, and the negative effects aren't necessarily the ones that are going to be borne out. So negative effects are not necessarily permanent if there's this supportive, enriched environment, depending on the stressor. Obviously, if it's very severe stressors, that's going to have more of an effect. And also, there's evidence that moderate life adversity shows a better performance in those sorts of social stress testing compared to children who've been under severe stress, or those who, even in the control group, who have had a normal amount of stress. So moderate stress seems to be actually good for performance. And before I finish, I just wanted to mention one other aspect. So up until now, I've been talking about childhood stress and childhood and adolescence. But of course, we know that the story starts way before then, during pregnancy. And there's work that's looked at the positive effects of increasing your child's brain capacity and cognitive abilities before birth. But in terms of physical health, there's also a lot of work that has looked at the negative effects on a child's health, on the birth outcomes, and on their subsequent health. But there's also, hidden in the literature, because we tend to look at more negative health outcomes, but hidden in the literature is also some evidence that some children actually become more resilient because of stress during pregnancy. And there's evidence for a greater body weight and length at birth. Even though children may be born earlier, they have physiologically become more resilient in the womb, if you like. Okay. So in summary, there's a whole life cycle of stress, and I've spoken about how prenatal, childhood, and adolescent stress can have a really significant effect because of the different levels of development that are occurring. But paradoxically, moderate amounts of stress, I'd argue, can be, so I'm trying to read there, and I can't read that small screen, can be very protective and facilitate the development of resilience. So I'm going to leave it there. Thank you.
Thank you, Julia. It's obviously emerging in my mind what stress is. It's not just a concept, right? I think it's what we call a super concept. It applies to so many things: pregnancy, adolescence, childhood. Is it good for you? Long-term effects. I've got a feeling that question time might run on. From first day at school to first day at Guantanamo. I guess it's kind of similar. Shane?
Thank you. Thank you for the chance to come and speak to you tonight. I'm going to talk about two things. One is really a difficult and quite abhorrent topic, which is the topic of torture. And I'm also going to talk about the neuroscience of interrogation, and these two things are linked. I'm going to give you a couple of caveats. First of all, torture is not a neuroscientific concept. It's a human rights concept, it's a legal concept, philosophical, ethical, or whatever you want to make of it. But in neuroscience, we're well used to the idea of talking about stress. We're used to talking about stressors, anxiety states, impulse states of pain, all of these kinds of things. And those kinds of states that are imposed in torture map reasonably well onto the kinds of things that we understand that happen in the brain as a result of these stressors. So I'm not going to talk any morality at all here tonight. The analysis is entirely consequentialist, so I'm not a Kantian as far as this talk is concerned. Okay, so I'm going to start with an assertion, you'll have to take my word for it, that there is no reliable historical evidence for the efficacy of torture in this particular case, which is as a veridical human information gathering practice. There's plenty of cherry-picked anecdotes, but there is no reliable body of evidence that shows that torture is a good way to gather reliable information from other human beings. There's lots and lots of historical evidence for this. This is a quote from Bonaparte from 200 years ago. You can get similar quotes from George Washington, from Lincoln, from lots and lots of other authors. Bonaparte puts it very simply. It has always been recognized that this way of interrogating men by putting them to torture produces nothing worthwhile, because the poor brutes will tell you whatever they want to make the pain stop. The modern historian of torture is Darius Rejali. This book is an amazing book. It's a very depressing and a very sad book to read, but it's well worth reading. Torture and Democracy. And in this book, Rejali makes the case that democracies have never given up torture entirely, that they resort to it under times of stress. And when you survey the archives of democracies and other states that have engaged in torture, you never find anything like this. There are no reports of its effectiveness, and people who believe in the effectiveness of torture need no proof and leave no reports. A really remarkable claim, but these do not exist when you go and look in the archives. They may have been destroyed in every country that he has investigated, which is about 160 countries, or they don't exist. I think it's the latter. They don't exist, and they don't exist for a reason that I'll elaborate towards the end of the talk. Okay, now this is the point that I want to get to. If torture is this, it's the attempt to force information from the unwilling. It has to be this. It's the effort to force information from the brain systems of the unwilling. It can't be anything else. It is that by definition. And this is the kind of information you want: declarative information, facts, events, knowledge of the world, these kinds of things. And we know which bits of the brain do these: the medial temporal lobe, this bit of the brain here at the side of your head. And this is the place where government theories, government policy documents, things like the torture memos, interface with what we know about brain function. Now, what does the brain do? Well, you've got, I'm sure, a good native sense of what the brain does. It's responsible for keeping us alive. It's responsible for our mood, our motivation, vegetative functions, cognition, our ability to think, our ability to behave through time. And the theory goes that if we take somebody who is unwilling to speak and we impose a supervening stressor state, hunger, thirst, cold, you name it, cold, heat, fear, anxiety, predator stress, physical assault, a state of pain, whatever. Somehow, over time, and when you look at what has been done, it's always a prolonged period of time. We're looking at months, weeks, and periods of time like that, not minutes, not hours. That somehow this will force the release of veridical information from long-term memory. In other words, information that faithfully describes what it is that the person knows. Now, we can go to the literature and ask, in a variety of different populations, patients, military personnel, volunteers, a whole variety of individuals, what the effect of these supervening stressors are on motivation, on mood, cognition, whatever. You have to hope it's positive if you're a torturer. You have to. At best, you hope it's negative. but you can predict that it's neutral. And at best, or at worst, it will be negative. And we can ask quantitatively what happens when these states are imposed on individuals. Now, here's just a simple example. You don't need to look through all the data here. This is a study of soldiers engaged in simulated combat. They've been starved, they've been sleep deprived, they've been liquid deprived over a period of 48 hours. And every measure of psychological state, from simple reaction time through to mood, through to their ability to remember simple events that happened to them just 2 days previously, is degraded, and degraded really, really dramatically. These are Special Forces soldiers from the US. This is something I'm sure you've all heard of. Waterboarding became a verb about 15 years ago. And this is a description of what waterboarding is from the torture memo that John Yoo wrote. In this case, the individual is bound on an inclined bench. Their feet are bound, and you place a cloth over the face, and you pour water on the person while they're breathing. And you have this amazing phrase that this effort, plus the cloth, produces the perception of suffocation and incipient panic, the perception of drowning. Now, you are actually drowning because the partial fraction of air in the lungs is blocked by the inflow of water into the oropharynx. So by definition, you are drowning because you cannot breathe through the nose or the mouth. We actually know what this position is. It's a surgical position, which is no longer used. It's the Trendelenburg position because it's extremely dangerous. People die in this position. It was devised originally for hypoperfusion of the brain, a condition where people didn't have sufficient blood flow around the brain. Now, what do we know? I'm sorry, this is a bit hard to see. We know actually, surprisingly, a lot about what happens to people under conditions of water-induced stress. Why do we know this? Because there's a very large literature on the physiology of diving. It goes back over 100 years. And this is an example of a volunteer. It's going to be very difficult to see here. But in essence, this is somebody who agreed to allow themselves to have whole body immersion in an ice cold water tank, which is, again, a very common method used for torture. And you get changes in heart rate. You get a sudden slowing in the heart. Here, this is bradycardia. And then a sudden jump in heart rate, tachycardia. And I'm sure you'll all have heard anecdotal stories of people having heart attacks from being exposed to cold water. This is what happens. Breathing, in this case, the person was only able to withhold their breath for around 10 or 12 seconds. So this is a volunteer, not somebody who's having it forced upon them. This is an example of a description of somebody being waterboarded in Siena. This is a picture of a woodcut that I took. And this is the description. The terror of drowning, endlessly repeated, is an agonizing torment, and it causes unimaginable anguish and all the rest of it. Now, what happens in more recent times? Well, here are some examples from the Senate torture report that was released 2 years ago. So Abu Zubaydah was waterboarded 183 times at 20 to 30 minutes a time. And in his case, it induced convulsions and vomiting. He became completely unresponsive with bubbles rising through his open, full mouth. And, amazingly, they extracted precisely no useful information. But rice and beans that he had eaten 10 hours previously did come back up. Really remarkable. Oxygen deprivation, we know a lot now about the physiology of oxygen deprivation. A plastic bag is a very, very good way of torturing somebody who's tied in a chair. Air hunger is possibly our most fundamental metabolic drive. Without air, every cell in our body will die quickly. If you ask people to voluntarily withhold their breath to exhaustion, what do you find? Joe mentioned the amygdala. You get a very strong activation in the amygdala, which is associated with fear and anxiety responses. If you experimentally reduce the amount of oxygen, this is a specimen result. Think of somebody climbing up a mountain and they're suffering from altitude sickness because they've got hypoxia. You can do this in the lab, and this is how you do it. You get somebody to wear a mask, and you reduce the fraction of oxygen, so from 20%, which would be normal, maybe down to 15, maybe to 12, maybe to 10%. And you ask them to do a variety of tasks. And this is what you find. every aspect of your perceptual life changes and changes for the worse. People report they're tired, they lose coordination, their vision becomes dim, they become weak, they feel sick, they feel faint. All of these kinds of things. Every aspect of cognition that you can measure degrades as well. People's cognition becomes worse. So their ability to remember information that they've previously learned is degraded dramatically by, in this case, about 30 to 40%. Their ability to respond quickly is degraded. Their ability to think, a measure of executive function, again degraded quite dramatically. You shouldn't be surprised by this, but torturers, I think, always are. Sleep deprivation is another very common form of torture, and there's a very large literature on the effects of sleep deprivation, which I won't go into. I just want to show you the single specimen result. Sleep deprivation is very commonly used in police stations as a method to get people to confess to crimes. They may not have committed those crimes, but it's very, very common worldwide. So if you bring somebody to your lab and you get them to participate in what's ostensibly a sleep deprivation study, and you bring them back and they either get sleep or they don't get sleep, and then in the morning a false allegation is made against them. So there's an ethical issue about these studies, but we can set that to one side. The allegation is that they've broken a piece of computer equipment. What you find is that people who are very sleep deprived are about 3 times as likely to admit to something that they did, or that they didn't do, compared to somebody who's slept normally. And this is in a very low pressure situation where you're in a university lab. It's not in a situation where you're imprisoned in a jail cell. So, come back to my question, does torture work? I won't say that it doesn't work for a couple of reasons. What I will say is this, that the signal to noise ratio is astonishingly low, and the false positive rate is astonishingly high compared to other non-coercive methods of interrogation. And this is why there are innocents all over the world who have been convicted on the basis of confession evidence. Torture is great if you want confessions. If you want to force people to repudiate a political stance, a scientific stance, it's really, really super. But if you want to gather reliable information, it's about the worst method possible. And field studies of experienced interrogators will show you that they all repudiate it as useless as a veridical information gathering practice. Okay, so I'm going to skip on a few slides. I just want to talk about a few other aspects of our pervasive interactions with each other, the self-reporting conversation, those kinds of things. It turns out that if you listen to people in cafes, out in the wild, in the field, about 40% of what people say to each other involves self-disclosure. Put that a different way, we like talking about ourselves. Don't be surprised by that, you shouldn't be. Even more interestingly than that, if you put people in a brain scanner and you ask them to engage in either personal disclosure or disclosure about famous third parties, this is what you get. You get a very strong activation in the brain's reward system when you're talking about yourself, but not when you're talking about somebody else. I think that's a good clue where interrogation is concerned. And people will do this even to the extent that it will cost them money. So they will gain lesser monetary reward during acts of voluntary self-disclosure compared to talking about somebody else. So we like talking about ourselves even if it costs us money. Okay, so there is a new science slowly developing of human information gathering. Is a big problem for the behavioral and brain sciences, but it's one that it can be solved. And it's one that's very important because law enforcement agencies engage in practices which are, shall we say, behind the curve in terms of what is required to gather information reliably from individuals. We now know a lot about what makes a good interrogator. And these are the kinds of things, I'm not going to go through the list here, but one of the things that they need to be is to be a very good actor. They need to have high levels of impulse control. They need to be very, very good at perspective taking, and in particular being able to take the perspective of the individual that they're talking to. And those kinds of variables are actually ones that have been sitting in psychology for about the past 50 years in areas like clinical psychology and also in psychiatry and clinical psychiatry, having a very good bedside manner. It is often said that in times of great stress, people will say, we are going to have to torture these guys, whoever these guys, and it's typically guys that get tortured. But interrogators will say this repeatedly, that interrogation should not be left to amateurs, because amateurs do not know what they're doing. And at the moment, we do not have, but it is being slowly put together, an experimental social psychology and an experimental cognitive neuroscience of interrogation. And this leads to a challenge because institutions, law enforcement institutions, the law, intelligence agencies and others have to change what they do in order that the science, the ethics and the policy are all lined up together. Thank you.